Hi guys, we're going to be looking at Unit 10 review packet circled problems for Quarter 4 recovery. We're going to start with just the circled problems, but if at any point in time you need to pause the video, rewind it, or just get some more practice for yourselves, you obviously see a lot of problems that are not circled, but very similar to what we are doing together. I'm not going to go through every question, I don't think, at least that's not my intention right now, because some of the questions are very similar to what we're going to go through together. Again, if you need to pause it, rewind it, stop it for just a second, that's totally fine. You do what you need to do to help yourself be successful. This unit requires you to factor a lot. There are 3 different methods for factoring. One is GCF, meaning there's something in common. 2 is DOPS, difference of perfect squares, and 3 is add multiply. You use a GCF when there's something in common. You use DOPS when you have perfect squares. And you use add multiply when there's 3 terms. Alright, so taking a look at number 2 to start. It says simplify each rational expression. So we need a first factor and then cancel out terms from top to bottom that are in common. So if I take a look at 12x plus 36, I know that there's something in common that I can pull out of 12 and 36. So think about it for a second. Find the biggest number that you can pull out of both of them. You might be thinking 6, but I think there's a bigger number. 10 doesn't work. 12. 12 parentheses. When I take this first term, 12x, and divide it by 12, I'm left with x. I'm left with a plus, and 36 divided by 12 leaves me with 3. Over. So now I've got a 3x plus 9. If I think about my options, I first look to see if anything's in common. Yep. That means we're factoring by GCF. Take a second to try that on your own. I'm going to do it up here on the video. If you need to pause the video for more time, then please pause it. So I factored by 3 parentheses x plus 3. Now I notice that I have an x plus 3 on the top and an x plus 3 on the bottom, so those cancel from top to bottom. So now I have 12 divided by 3, except that can be reduced. We're trying to get it in simplest form, so 12 divided by 3 is just 4. Okay, so now we're going to take a look at number 4. Number 4 starts us with 6 parentheses a squared minus 16. So if I look at a squared minus 16 and think about that for a second, there's nothing in common between a squared and 16, so it's not GCF. So then my next option is DOPS, difference of perfect squares. A squared is perfect because it's squared, and 16 is perfect because I can take the square root of 16 and have a nice number. So we're going to factor this by DOPS. So you have 6 parentheses, parentheses. DOPS has 2 pairs of parentheses. A squared can be broken up into A and A. 16 can be broken up into 4 and 4, one with a plus and one with a minus. All over 4 minus A. I notice that I have an A minus 4 and a 4 minus A. Those are pretty similar to one another, and in fact they can cancel, but they cancel to a negative 1. Now you might be wondering, well, why do they cancel to a negative 1? It makes no sense. Give me a second to explain it to you. If we had, say, 4 minus, not 4, let's do 6 minus 4, over 4 minus 6. Same numbers, but in opposite positions. 6 minus 4 gives us 2, and 4 minus 6 gives us negative 2. When I simplify those, it gives me negative 1. It happens every time, no matter what pair of numbers you choose. 10 minus 3, 3 minus 10. 7 over negative 7, negative 1. Okay, so when you cancel opposites with subtraction, it has to be subtraction and only subtraction. When you cancel opposites with subtraction, it gives you a negative 1. Okay, So now we're moving on. Not with the next problem, but with this problem still. On top, I see a 6. I see an a plus 4. And then don't forget about that -1. I'm going to choose to stick that in the front of the 6. Because -1 times 6 becomes a number. -6, parentheses a, plus 4. There's nothing left on the denominator, so we're done just like that. Take a second to factor the numerator, x squared plus 2x. Hopefully you recognize there's a GCF of x, so we have x times x plus 2. For the denominator, there's 3 terms, so our method here should be add, multiply. 2 pairs of parentheses, x, x. We're thinking of numbers that multiply to 8. Sometimes it's helpful to write the factors off to the side, like 1 times 8, 2 times 4, and we're looking to add to a -2. So that means we're going to choose 2 and 4. Because we're multiplying to a negative, the bigger number takes the first sign. So bigger number takes the negative, smaller number takes the positive. From here, we cancel from top to bottom. Plus 2, x plus 2, gone. So now on top, we have an x. On the bottom, we have an x minus 4. And we're done. Do not try to cancel those x's, because the second x has a -4 attached to it. If it were an x over 4x, then sure, yeah, you could cancel and have 1 over 4 left over. But here, the -4 makes the ballgame a little bit different. We cannot cancel the x's. Flip it over to the next page so we can see a little bit more with simplifying in terms of multiplying and dividing, though. Okay, so we're like 4 pages away now. Taking a look at number 19 to start. 19, 20, 21, and 22 are all fair game. If you see multiplication, we didn't do just multiplication problems. Your test may just have you doing, say, something like this first section, or your test may have you doing something like just this second section, where you're just multiplying fractions or you're just dividing fractions. But your test is also going to ask you to do a combination of things, multiplying and dividing. So I figured that we'd just save ourselves some time, work on the combination of things because it's the same process. If you see multiplication between fractions, you keep both fractions just the way they are. But if you see division, you need to keep the first fraction, change division to multiplication, and flip the second fraction. Keep, change, flip. So second fraction has to be flipped upside down. So start by rewriting everything, except for the last fraction gets flipped upside down. So from here, we're going to factor everything that we possibly can. The y plus 2 in the first fraction cannot be factored, so it stays. The y squared minus 9 can be factored. Think about your 3 options: GCF, DOPS, or add multiply. I'm going to have you pause the video, factor everything, and then hit play when you're ready to see what the factors should be before you cancel out terms. So again, pause the video, factor, and then hit play when you're ready to see what the terms should look like once you've factored. Okay, so you can see all of my factors. I tried to color code things for you. I tried to write out how I factored each part so that it would make your life a little bit easier when you're looking at my answers here. So you can see like the blue box here, I factored by DOPS, and it turned into y plus 3, y minus 3. When you check your answers here, be careful of your signs. You need to have the same exact signs that I do. So if I have a plus 3, you need a plus 3. A minus 3 just doesn't work there. Okay, so make sure that you get the same exact signs as I do. From here, we're going to cancel from top to bottom. So starting in the top left, I see a y plus 2. So now I'm looking at the bottom, looking for a y plus 2, and I see one, so I cross them both off. you can only cross off in pairs. So if there were another y plus 2, I could not cross it off unless there were another one on the top. Next, I see a 4. I see no 4s down at the bottom, so I'm going to leave the 4 for now. Then I see a y plus 3. I do see a y plus 3 on the bottom, so they both go. Top to bottom, cancel. Next, I see a 2. I don't see any 2's on the bottom, so we'll leave it for now. Then I see a y minus 3. Y minus 3 is on the bottom, so they both go. My next thing is to take anything left on top and smush them next to each other by multiplication. So 4 times 2 on top. On the bottom, we have a 3 times 8. 4 times 2 gives me 8. 3 times 8 gives me 24. But this can be reduced. So we're going to reduce it to a 1/3. Box it in, and you're good to go. Then we're going to take a look at number 21. I want you to start this process by keep, change, flipping, whatever it is that you need to keep, change, flip. Well, I don't know what it is. Look at the previous example. Write down what your new problem is, and then start factoring. If you need to pause the video for more time to write down your new problem, then just pause it. Otherwise, take a look at mine, make sure it's the same as yours, and start factoring piece by piece. Take the top of the first fraction, factor it, pause the video while you're factoring, and then hit play when you're ready to see my factors again. Alright, so I have all my factors, again, color-coded and with the factoring method written right next to them. Take a look at the signs, make sure it's exactly the same. If you need to pause the video while you're checking your signs, that's fine. From here, I want you to start canceling terms from top to bottom. While you cancel, pause the video. Then we're going to take a look to see what's left over so that we can write our final answer. Okay, so when I cancel stuff, I see that I have a 6x squared left on top, I see a 3, and I see a 4 on the bottom. So when I have my final answer, I have 6x squared on top, 3 times 4 on the bottom, which we know gives us 12. But final answer is not ready until we reduce. So 6 over 12 can be reduced into 1x squared over 2. If you just simply have x squared over 2, that is a perfectly acceptable answer. And then we're done. If you need more practice like this, go back and try numbers 20 and 22. Otherwise, we're moving on to adding and subtracting rational expressions. When you add and subtract, I've got this reminder here for you. Get a common denominator by taking the denominators and multiplying them together. So our first step in number 25 is to write out denom, take our denominators and multiply them together. X parentheses x plus 3. Multiply the tops and the bottoms of each fraction by what it's missing, it says. So I have a fraction on the left that has a denominator of x, so it's missing x plus 3 on the top and on the bottom. The fraction on the right has an x plus 3, so it's missing an x on the top and on the bottom. So now I make one big fraction with my one big denominator, and on the top part we have 5 times x plus 3. Make sure the x plus 3 goes in parentheses, otherwise you're going to lose some distributing. Then on the top we have plus 7x, well 7x times x is 7x squared. From here we distribute. So we have 5x plus 15 plus 7x squared over x times x plus 3. If there's like terms to combine, then you combine them. If not, you leave it. This one has no like terms, so we're done. Number 27 is another pretty common problem. If you see a minus sign in the middle of your fractions, you're going to change it to a plus, and then you're going to put a negative in front of the next fraction. We're going to add the opposite. So it's okay to do that. We don't like minus signs in between our fractions because they get lost sometimes. So now you go through your process, denom. Just because there's an x plus 5 and an x minus 3 does not make a difference. Take your two fractions, or take your two denominators and put them next to each other with multiplication. Multiply each fraction top and bottom by what it's missing. So the left fraction was missing the x minus 3, and the right fraction was missing the x plus 5. So now we have x times x minus 3 minus 2 times x plus 5 all over our big denominator. This would give you, say, 1 out of 2 points. From here, you need to distribute. Then, combine like terms. If you cannot factor, if you cannot combine anymore, then you're done. So we end up with x squared minus 5x minus 10 over x plus 5 times x minus 3. If you want other problems like this, 28 is a good question. And so is number 24. 26 is a little bit different. We're not going to focus on that though because you're not going to see one like that on your test. Flip it over and we'll see another problem or two like this before we get into rational equations. Number 32, very similar to the one that we just took a look at. Remember, change the minus to a plus and put the negative with the second fraction. Think about your denominator. I have an x plus 5 and an x minus 1, so smush them together with multiplication. Multiply by what it's missing. Make one big fraction with a one big denominator. And think about how to write your numerator. On the top we have a 2, parentheses x minus 1, minus 3, parentheses x plus 5. Remember, from here you distribute and combine like terms. Final answer, if you need more time, just pause it. Final answer should be negative x minus 17 over x plus 5 times x minus 1. Number 30 and 31 would be fair game for your test as well, so if you need more practice, try those too. Otherwise, we're going to move into something called solving rational equations. So again, I have a big reminder here for you. It says get a common denominator, just the same way we were doing before, multiply all the denominators. And then it says multiply the tops by the whole denominator and cancel out the denominators. So first things first, put anything that's not a fraction over 1. Then from there, identify your denominator. So I have a 4, I have a 3, and I have a 1. 4 times 3 times 1. Because of this equal sign, that makes the difference between the problems we were just doing and the problems we're going to do now. Equal sign means multiply by everything. Okay, so we have 4 times 3 times 1. 4 times 3 times 1. 4 times 3 times 1. And every single fraction, even if there's 4 of them, take all 4 denominators, multiply it by every part. If there's 6 of them, take all 6 denominators, multiply it by every part. So now what we're going to do is cancel out from top to bottom, kind of like what we were doing earlier. There's a denominator of 4, so it cancels out with the 4 that I was multiplying by. So now I have 3 times 1 times x minus 4. 3 times 1 is just 3 times x minus 4. No more denominators. Okay, they go away completely. I'm just going to move this down a little bit so I have room. 3 parentheses x minus 4. In the next one, the 3 in the denominator cancels with the 3 in the numerator. So now we have 4 times 1 times x. That's plus 4x. And on the right-hand side, we have the 1's canceling. So now we have 6 times 4 times 3. 6 times 4 is 24, times 3 more is 72. So from here, we're solving equations just like normal. Distribute, combine like terms, solve for x. I'm going to do it quietly up here on the video. If you need to pause it, remember pause it. This is for you to be successful. So you'll actually notice if you try to check your answer with the answer key, my answer is wrong because in my answer key I tried to subtract 12 from 72 instead of adding it. So final answer for this should actually be 12. X equals 12. Flip it over so we can take a look at other problems. If you want to take a look at 34, that's fair game too. Remember, put the right side, the number over 1, figure out your denominator, so on and so forth. Otherwise, turn with me. So we're going to take a look at number 36. First thing I see is a minus in between fractions, which we don't like, so change it to plus, move the negative to the next fraction. Second thing we want to do is figure out our denominator. I see an x, a 4, and an x minus 1. So I'm going to make that 4 times x minus 1. Notice that I put the x minus 1 in parentheses. That's just going to help us when we have to distribute later. So multiply everything by 4 times x minus 1. Doing that, remember, helps us cancel denominators, and the reason we multiply by everything is because we see an equal sign. So in the first fraction, x's cancel. So now we have 6 times 4 times x minus 1. So that means 24 times x minus 1. Then we have x minus 1's canceling. So negative 9 times 4 times x. That should be negative 36x. On the right side, 4's cancel. So now we have equals 1 times x, which is just x, times x minus 1. From here, start distributing. You may want to write small for this problem. It is a little bit of work here. Combine any like terms that you see. And then notice that we have an x squared in this problem. Whenever we see x squared, we need to get the equation equal to 0. And keep the x squared positive. So x squared is already positive, which means I'm going to move the left-hand side with the 12x and the 24 over to the other side. So now we have 0 equals x squared plus 11x plus 24. From here, think about add multiply. We're going to factor. Numbers that multiply to 24 and add to 11. If you need more time, just pause it. I found positive 8 and positive 3. So then when I t-chart, I get x equals negative 8 and x equals negative 3. Both of these are valid answers. The only time you should be checking, or the times that you do need to check your answers, are when you have denominators with something like x or x minus 1. Your denominator cannot be equal to 0. So say you got an x value of 0, we would have to reject it. Because if I plugged in 0 right here in this first fraction, I would have 6 divided by 0. That just doesn't work. You can't divide by 0. So you reject it. In this case, with the x minus 1, if I got, say, x equals 1, 1 minus 1 would give me 0. So I'd have to reject this. Now clearly, negative 8 and negative 3 are okay. We can have denominators of negative 8. We can have denominators of negative 3. That's okay. So we're going to move on. Take a look at 37. Remember, if there's not fractions already, make them into fractions. And then write your denominator. And because there's an equal sign, multiply by that denominator on everything. Once you've done that, cancel out denominators with a term from the top. And write down whatever's left over. So when I cancel, I end up with x squared plus x equals 72. Again, I see an x squared. It's already positive, so I want to get this equation equal to 0 by subtracting 72. I'm going to leave you to it to factor by add multiply. Pause the video while you do it because I'm going to write my answers up here so that you can check it when you're done. Remember, factor and then t-chart. So I found x equals negative 9 and x equals positive 8. Take a look at number 38 when you're ready. Start by finding your denominator. Process always starts the same, no matter what. While you work through number 38, I'm going to work through it on my paper silently. I'm going to cancel out denominators. I'm going to write whatever's left over. I'm going to solve for x. If there's an x squared, I'm going to get it equal to 0, so on and so forth. If at any point in time you need to pause it, feel free. If you need more time, hit pause. Otherwise, I found my answer to be 6/13. So with that, that's our last question together. However, you are welcome to try any of the other problems. Something like 39 would be good to try. Let's see, 39, 42 would be good to try. Even 40 would be good to try as practice before you take your assessment. Another good problem might be 45, 44, that kind of thing. If you need to go back and rewind, please do. Otherwise, move on to more practice or your assessment if you're ready. Remember, if you don't pass the assessment, then you have to come back and practice again. So please make sure that you are ready to take your assessment before you do. If you have any questions, just ask your teacher. We are more than willing to help you. Good luck.